Hey, my name is Riley McBride, and I am the project lead for the 2020-2021 NASA Student Launch Competition. So we're a senior design 1 team. So far, it has consisted mostly of documentation and design. In the second semester, we're going to get a little bit more into the building and the testing. So the requirements for our project are to design and build a vehicle that reaches an apogee of 3,500 to 5,500 feet. We predicted our apogee to be 4,900 feet. So the second half of the project is to design and build a payload, and that payload needs to be jettisoned from the launch vehicle between 500 and 1,000 feet during the descent. And after it's jettisoned, it has to land, it has to self-level to within 5 degrees of vertical, and has to take a 360-degree panoramic photo of the landing area and send it back to the launch station. So an additional thing we pride ourselves on here as the UNCC rocketry team is the engagement. So part of the competition is to engage and educate children and in the kindergarten through 12 community, and we have to do a minimum of 200, and we look forward to exceeding that. So we're going to start out with the outreach here, and one of our projects was to collaborate with Kids Fest, and we made bottle rockets for kids, and it was streamed on Facebook Live this year. It's been a little bit different with the COVID situation, but that's something that we really pride ourselves in. In terms of budget and the funding, we did a fundraising event where we raised $10,000, and that is in there under crowdfunding. We also got a sponsorship from Sunbelt Rentals, which was $7,500. We received $5,000 from the state, and we have some rollover funds. So that brings us to a total of $26,500 that we're allowed to spend, and we are planning on spending $20,000. So then we have a summary of our vehicle. It's supposed to go to 4,900 feet, and it uses a reloadable solid fuel motor, and that is an L-class motor. As you can see, it's about 86 inches in length, and it weighs 24.5 pounds. The Atlas is the name of our payload. It stands for Autonomous Terrestrial Lander and Surveyor, and it's going to be 3D printed, most of the body, and it's going to have steel legs. And we are designing a control system which will self-level using 3 legs and a linear pusher in the middle. And it will also have 3 cameras to take the panoramic. So in the top right, you can see the recovery portion of the project. We're going to have 5 different parachutes. So the vehicle goes up, it separates into 2 pieces at apogee, it deploys 2 small parachutes, and then as it goes down, it deploys 2 more main parachutes. At 500 feet, the payload deploys. So in the bottom right, it kind of shows our self-leveling and our image transmission. And it's going to autonomously self-level, so we got to write that code ourselves, and it's going to capture some images and use RF to transmit them back to the launch pad.